everyone, this is Greg, K4HSM, and I'm here today with another edition of Ham Radio 101. And today we're going to talk about what all those different meter bands mean, why Citizens Band is called 11 meters, and why the most popular band in ham radio is 2 meters, and how you can figure out what meter band you are on with simple mathematics. We're also going to talk about wavelength and how it pertains to these meter bands. So stick with us. Okay, so what you're looking at here is what's known as the U.S. Amateur Radio Band Plan. These are all the frequencies that are allocated for ham operators in the United States. The ones we're going to focus on today go from about 160 meters here, that's from 1.8 megahertz up to 2 megahertz, all the way to the microwave bands over here on the lower right. So you'll notice that as the frequency increases, the number in the meters decreases. So you have 1.8 megahertz up to 2 megahertz. That is the 160 meter band. Then you go up to 80 meters, which is from 3.5 to 4 megahertz. And then 40 meters goes from 7 to 7.3 megahertz. Then 30 meters, 10 to 10.1 to 10.15 megahertz, and so on. 2200 meters, still an experimental range, but it is known as low frequency, or LF. Then you have 630 meters and 160 meters here. These are known as the medium frequency ranges, or MF. To give you an idea of where the 160 meter band is on the radio spectrum, the AM broadcast band is right below this, from 540 kilohertz all the way up to 1.7 megahertz. So from 80 meters down to 10 meters, from about 3.5 megahertz all the way up to 29.7 megahertz, which is in the 10 meter band, you have what's known as HF, or high frequency. Then 6 meters, 2 meters, and 1.25 meters, also known as the 220 band, that is known as VHF. Then from about 300 megahertz all the way up to 3 gigahertz, so basically the 70 centimeter band, 33 centimeter, 23 centimeter, and a couple of these microwave bands down here, you have what's known as UHF, or ultra high frequency. Above those frequencies in the microwave spectrum, you have what's known as super HF, or SHF, which goes from 3 to 30 gigahertz. Then you have extremely high frequency, or EHF, which goes from 30 to 300 gigahertz. And then you have tremendously high frequency, or THF, which goes from 300 gigahertz and above. Okay, so how do we determine the meter band for each of these frequency ranges? Well, it's a simple mathematic equation. What they do is they take the number 300 and divide it by the frequency in megahertz. So if I take 300 and divide it by the 160 meter band over here, the middle of it's at 1.9 megahertz. So I will divide by 1.9, and you come up with about 157.8. Rounded up to 158, pretty close to 160 meters. Same thing we do for the 80 meter band. We'll go 300 divided by 3.8 megahertz, which is about the middle here of the band there. And you got 78.9 or 79, rounded up to 80, the nearest 10. Sometimes when they talk about the upper portion of the 80 meter band, so if I do 300 divided by 4, 4 megahertz, it'll come out to 75. So sometimes you'll hear the upper part of the 80 meter frequency range referred to as 75 meters. So we can continue this on with pretty much any frequency range that's on here. So again, I will clear this out and go to 300 divided by 144. Actually, we'll do 146 because that's the middle. And you get 2.05 meters, or 2 meters. And just for good measure, the Citizens Band, they often refer to that as 11 meters because 300 divided by 27 megahertz, which is the majority of the range of frequencies in Citizens Band, comes out to 11.111, etc., meters. So what does the meters mean? What exactly are we referring to? Well, when you take a wave, a sine wave, for example. You take a complete waveform and you go one complete cycle. The distance of that cycle is what is the meter band. So imagine these radio frequencies as a physical entity. If you take a sine wave, an actual signal wave, and you convert it to a physical form that you can see and touch and feel, then if you key up the microphone on those frequencies and just throw a dead carrier, the frequency will go in a form of a sine wave, typically on analog, or a square wave on digital. This is an example of a sine wave. So the wavelength from a particular point on the graph to make a complete cycle back to the same point on the x-axis is what you're looking for. So we'll start here at the x-axis and go one complete cycle back to the x-axis, easy for me to say. That right there is one complete wavelength. You can also do it from the same point. It doesn't have to be on the x-axis. So down here at the bottom of this wave to the bottom of the next wave could be considered one full wavelength as well. So if you were to make this a physical form, the distance of that particular wave may not be very big, but on the 2-meter band, the most popular ham radio band, it would be about just a little over 6 feet long. 160 meters, if you were to equate a distance, is about 525 feet. So you're probably asking, okay, why is my antenna not 525 feet long if I want to get on 160 meters? Why is my antenna on my HT, my handy talkie, not 6 feet tall? Well, there are reasons for that, which we'll cover in another topic. Just know that there is what's called the quarter wave, half wave, full wave, 3/4 wave, 5/8 wave, and so on and so forth. And what they are is a portion of the wave, and you can transmit a signal on just a portion of the wave without compromising the reflectivity of that energy going back into the transmitter. So again, you'll notice that the frequencies, as the meter band goes up, the frequencies get lower. Those lower frequencies on HF and below, or HF and higher, depending on how you look at it, they tend to be more of a propagation type of frequency range. So HF is very popular for stations that want to communicate beyond the line of sight or beyond the horizon. So you can be on the 20-meter band, one of the more popular HF bands, and you can be at your home here in the United States, and you can talk to Canada, you can talk to Mexico, you can talk to Europe, Asia, you can talk all over the world on the 20-meter band, usually in the daytime hours and early nighttime hours. In the 6-meter band and higher, it's usually line of sight. Now, 6 meters and 2 meters and even 220 occasionally will have propagation due to a wide range of circumstances, which we'll talk about in a later video. But every now and then they will go beyond line of sight. But for the most part, they are within the footprint of where your signal can reach without going up into the atmosphere and bouncing down. And what you're seeing here is an example of propagation on the 2-meter band based on APRS beacons. These are packet beacons that are being sent out on a common frequency and being relayed through iGates or internet gateways. And anything that seems to, when these packet bursts go beyond a certain distance, then it may be considered propagation beyond the line of sight and could be an indication that there is a band opening on the 2-meter band based on what these packet bursts are doing and who's receiving them. So usually the lower the frequency, the better the odds are of going into a propagational beyond line of sight type of communication. So the simple answer is basically take 300, divide it by the frequency in megahertz, and you have your meter band, give or take. And so with that, this is Greg, K4HSM, saying 73s. Next week, we will have another Ham 101 class, and it'll be on what all those Q signals mean. What does QST, QRZ, QSY, what does it all mean? We'll talk about it next week.